Hello there, this is Lana Tucky. I'm going to be showing you in this video how to use your calculator to help you run a paired t-test for the mean. So we have some data here, which is the Reiki touch therapy data. These are patient pain levels before they had this touch therapy, and then these are the patient pain levels after. So what I'm going to do is I'm going to type those 2 rows worth of data into my calculator. So I'm going to go to Stat, Edit, clear out my old column. I'm going to type in those values. So let me make this go away so I can see them. 6, 2, 2, 3. Okay. And then we go to the right and type in the next ones. Remember, we don't care about the patient numbers. That's just a way of labeling them. They could have called them, Spain, Portugal, and so on. They could have given them any name they wanted. So all that matters to us is the pain level before, that's L1, and the pain level after, that's L2. Now in this particular problem, we've set up that we want after minus before right there. So look for a comment like that somewhere, and if there's no comment like that, then it doesn't really matter which way you go. So we want after, take away before, but after was an L2 and before was an L1. So let me pull my calculator up. I'm going to go over to the right to L3, go up to the top, so the top is highlighted. I'm going to take L2, second 2, which is the column that had the after data, minus second 1, that's L1, enter. And there we go. It found all the differences for us. So -3, -1, 2, and so on. All right then, so that's our first little trick. So now we've learned that. And then later on, we want to be able to run the test itself. Oh, finding D bar and SD. D bar, since we found all the differences in L3, D bar is the average of those differences, and SD would be the standard deviation of those differences. And you can find those a couple ways. One way you can do it is running one variable stat. So let me show you that real quick. So we go stat, calculate, one variable stat, but we want to tell it L3 this time, so second 3. We'll leave frequency list blank. That's only if we wanted a weighted mean. Go down to calculate and press enter. And there it is, -1.923. Of course, the calculator doesn't know what these are, so it just calls it X bar. So you have to know that that's actually D bar because these were differences. And there's S, your standard deviation. So that's SD, the standard deviation of differences. So it's 1.605. Okay, so that's a review of how to find that. And now we're going to actually help ourselves run the test with the p-value method. So scroll past all these instructions. And let's look here. We're doing a left-tailed test right here. So we chose to do a left-tailed test. And we're going to have the calculator help us by finding all these values. So let me go to Stat, Tests. And at the top of the page that has the instructions, you can see, let me scroll back just a minute. Not there, right here. The inferential sheet that's on your note sheets for the test. You can see right at the top I say to use a t-test. So that's what you're going to do. You're going to use a t-test. It works a lot like t-test from chapter 10, but it's just a t-test of differences, which you kind of have to know in your mind. All right, so we're going to run a t-test. So let me grab the calculator. So we're going to pick number 2, t-test. Now we have a choice here of data or stats. So if we pick stats, then, ooh, look, since we ran the one variable stats, it actually knows the 2 statistics we're interested in of -1.923 and 1.605 and 13. If we hadn't run one variable stats, we'd have to type them in our own self. But we actually have a column of data on this one, so I'm actually going to go with data. Now, what's mu0? Mu0, 0 is your zero hypothesis, your null hypothesis, which says that the mean differences is equal to 0. So I'm going to go back here and type 0 for my mu0. Now, my list of data is in L3 for this problem, not L1. L1 was before. I want the difference data. That's L3. Frequency list we're going to leave as 1. And we're not doing a two-tailed test, we're doing a less than test. So I'm going to press enter right there and make it so the blue one, or excuse me, the less than one is dark. I'm going to go down to calculate. and press enter. And there it runs it. It tells us that the t-score is negative 4.319. Our p-value is right there with p. And you can see the d-bar right there is negative 1.923 and 1.605 is s. So actually, it figured out those two values and the n value without the one variable stats. So if you have your data, the t-test will find those values for you. So there's the negative 4.319. That's right at the top of the output. Right here, negative 4.319. And then look at the p-value. Remember that p stands for probability. So there's no way a probability is 4.98. What it is, see over here on the right, it's scientific notation. So it's 0.000498, which is a totally different story. Right here. So it's 0.000, actually it's 0.0005. Right? I should have rounded that. Okay? Oh, I did round it right over here. So there's your p-value, and it's so low you reject. But be careful. If you see scientific notation, watch out for that. P-values are often very, very small. So you'll have scientific notation a lot. Never, never, never say your p-value is anything over than 1, because that shows you're not understanding what's going on. A p-value is a probability. The entire curve makes 1. So there's no way this little shaded tail over here could ever be over 1. And it isn't. And let's see what else. Oh, just a quick review of how to find that value right there. So if you're doing the classical method, this is a left-tailed test. So all of alpha, which is 0.05, is over here in the left tail. And your degrees of freedom was 12 because n was 13. So if you have your 84 calculator, you can find that value by saying second variables, hit the inverse t function. We want 0.05 and 12 degrees of freedom. Enter. And then hit enter again, apparently. And negative 1.78. Negative 1.78. Oops, now we want to make sure we know how to use the tables as well, just in case, because the TI-83 calculator won't have that inverse t function. So remember the area in the tail was 0.05, so go to the t distribution table. Pick 0.05, go down to 12 degrees of freedom. That's 1.782. Now this only gives right tail areas. It's only right-tailed test critical values, if you will. So if you're doing a left-tailed test, you just have to make it negative, which we would in this case because we're working with a left-tailed test. All right, so that's how to use the calculator to help yourself run a t-test, find the differences, and then find the statistics about those differences, namely d-bar, SD, and n. Now, it wouldn't hurt us to also remind ourselves how to find a confidence interval. So let's go back here. So we want the confidence interval for the difference in pain level. So let me go grab the calculator. I'm going to do stat tests. And just like you did a t-test, now you want a t-interval, which is number 8. And again, you have the choice of data or stats. I have data and it's in L3, so I'm going to stick with the data. If you wanted to, you could go to stats and enter the statistics yourself. Right? Of course, if you're rounding, you'll be a little bit less accurate. But if they don't give you the data in the problem, then they must have given you the stats somewhere. All right, and we want a confidence level for this problem of 95%, so 0.95. Go down to calculate, enter. And there we have it, negative 2.893 and negative 0.953. Oops, wait, come back, which are right here. There's your results, right? So at least that way you have the final results. It's running all of this calculation for you. Nice. And that means we're done with section 11.2. I'll see you back here for 11.3 and 11.1. See you then.